Hello everyone. Welcome to the logical reasoning and data interpretation section discussion of mock level. So first let's go through the questions, identify the easy questions. Let's rate the questions as per the difficulty level, and then again let's have an overall analysis of the section, and then we'll comment on the ideal score that a student with good preparation should get in this mock. Okay, so let's get started. So first question. Question from data interpretation, web graph or a spider graph or spiral graph. Okay. So answer the question on the basis of information given below. So the following spider chart gives details of the number of vintage cars which are 65 to 80 years old of different types of cars at a museum during the years 2016 and 2019. So we are given with the number of vintage cars which are 65 to 80 years old. Okay, so we are given with a number of cars which are between 65 to 80 years. We do not know the age of the each car. Okay, how old is that? Now it is given that the total number of cars in the museum was 80. So let's remember this statement. Now, no car was sold or added in the collection during the period from 2016 to 2019. So, if you have any change in the number of cars of a certain model, number of vintage cars in a certain model, for example, for the year 2016, the number of convertible cars which are vintage are 24, and in the year 2019, 12. Okay, so 12 among these convertible cars have crossed 80 years old, isn't it? Okay, so that's my analysis here, and it is also given that the total number of cars in the museum was 80. No car was sold or added in the collection during the period from 2016 to 2019. So this question had a flaw, guys. Okay, now it is given that the total number of cars in the museum was 80, isn't it? So if you observe in 2016, the number of vintage cars are itself 80. And in 2019, so 12 cars of convertible have crossed 80 years old. Okay, so there should be a reduction of 12, minimum of 12 numbers from these 80 in the year 2019. So, but when you add up these numbers, you'll be getting 75. Okay, so there is a flaw in this question. It is given that the total number of cars in the museum was 80. So this should not have been mentioned. So that's my analysis of the given state. Because if the number of cars were more than 80, so I can also say that there will be cars whose age is less than or 64 years or 63 years in the year 2016. So in the year 2019, okay, so those cars can enter the vintage cars category here. Clear? So this is the flaw in this question. So I assume students to spend around 4 to 5 minutes on this question thinking that this is easy. Okay. So if I remove this statement, then this becomes an easy question. Clear? So this is the reason I rate this question to be hard. So if you guys have tried attempting this question for 4 or 5 minutes, then it's a waste of time. Now, coming to the second set. Now here we are given that for row 1 there are 4 bags, each represented by filled circle. So each circle represents a bag kept in each of the 4 slots of the first row in a 4 by 4 grid. So this is the first row and first column. Okay. Now each bag has a certain number of cherries, and the number of cherries will be in the order x minus 3, x plus 4, x and x plus 2. Among these bags of row 1 are given in the table, and we are given with the number of cherries in the bag. For example, we know that among the 4 bags in the first row of the first column, the number of cherries will be 2, 9, 5, 7. So how did you get these 3 values? Because the number of cherries in these bags will be in the order x minus 3, x plus 4, x and x plus 2. Okay, so this bag has, it is given that this bag has 9 cherries in it, so x plus 4 will be equal to 9. So the value of x is equal to 5. So this will be 2, this will be 5, and this will be 7. So similarly, here in the first row, second column, we are given with the value of x. X is equal to 8. Here, x minus 3 is equal to 7, and x plus 4 is equal to 12. So from this given data, we can determine the number of cherries in each bag in row 1. Now for row 2, there are 3 bags in each cell, perfect, kept in each of the 4 slots of the second row in 4 by 4 grid as shown in the figure. So each circle here also represents 1 bag. Now each bag has a certain number of cherries. Now the lowest and highest number of cherries among these bags of row 2 are given in the table. So 4A, 9. So these are the 4 is the lowest number of cherries and 9 is the highest number of cherries in these 3 bags. Okay. And the number of cherries in the middle bag is square root of multiples of number of cherries in the other 2 bags. For example, we know that among these 4 bags in the second row of the first column, the lowest number of cherries is 4, the highest number of cherries is 9. So the number of cherries in the other bag will be under root 4 into 9, which is equal to 6. So the same logic will be applied for all the bags in this row. Done. So we can find the values of A, B, C, and D. Now in row 3, there are 3 bags again kept in each of the 4 slots of the third row. Okay. Now what is the logic to determine the values of P, Q, R, and S? Okay, the data of 2 bags is given in the figure and the number of cherries in the third bag is unknown, which can be found with the help of following data. For example, in the third row, the first column, the number of cherries in 2 bags is 4 and 2. And the number of cherries in the third bag will be the sum of 4 and 2. So the value of P will be 6, Q will be 7, R will be 10, and S will be 9. Now to find the values of R minus 1, and 3R. In the 4 by 4 grid, the number of cherries in the diagonal slots is equal in number. For example, the sum of the cherries put in all the bags of different slots of row 1, column 1, row 2, column 2, row 3, column 3, and row 4, column 4. So the sum of the number of cherries in all these bags together will be equal to the sum of the cherries in all these bags. So you can find the value of. So once you have the values of all the variables in this question, you can answer these 4 questions. So comparing first question and the second question, second is the easier one. And I can also say that this is a very easy question. All you need to do is you need to find the values of variables. That's it. Perfect. Now, a partner-based consulting firm was celebrating the success, so they organized a party for employees. Perfect. So in the party, total 3 types of cool drinks were served, namely Nimca, Sprite, and Mountain Dew. It is known that a total 400 members were present, but there were 22 members who didn't drink any of these 3 types of cool drinks. Then further, it is also known that 600 bottles were served in the party. Okay, so this tells me that this is a 3-set Venn diagram, which we will be having some variables using which, and we are given with these 5 statements using which we need to determine how many bottles of Nimca were served in the party, how many employees drank Nimca, Sprite, and Mountain Dew, and so on. So if you consider yourself good at Venn diagrams, you can solve this set. I rate this easy, okay, because not much of variables are involved, or you are not asked to find maximum value or minimum value of any of the parameters. So if you observe how many bottles of Nimca were served in the party, how many employees drank only 1 bottle, what is the difference between number of employees who drank Nimca and the number of employees who drank Sprite. So there is no question on finding the maximum or minimum number of persons or minimum number of bottles. Okay, so this is a closed set because you are asked to find the definite values. So which I consider to be a doable question from Venn diagrams. So in Venn diagrams, if someone wants to complicate questions, then you will be asked to find maximum minimum values. Okay, for which you need to spend some extra time to solve those questions. Clear? Now, a Venn diagram based on definite values is definitely a doable set. Okay, but if I compare this with the previous question, I will be solving the second set first, and then I will be solving this question. Now, the question is based on the following information. 7 colleagues A, B, C, D, E, F, and G decided to watch a movie exactly on one day among Friday, Saturday, and Sunday. Each visited exactly one fast food joint among Domino's, McDonald's, and KFC after the movie. So at least 2 colleagues and at most 3 colleagues watched a movie on each day. At least 2 and at most 3 colleagues favor each joint. And you are given with 6 statements. And you are asked 6 questions based on this. Okay. So first thing, when I compare the first 4 sets, I will be attending the second set for sure. So set number 1 has a flaw in it. So between this set and the Venn diagrams one, I will be attempting this set because I consider puzzles as my area of strength. Okay. Or Venn diagrams also. So you can pick any out of set 3 and set 4 after doing set 2. Now read the following information carefully and answer the question that follows. So the last set in the exam. So Mr. Bruce, a school sports instructor, is preparing students for a parade to be held on annual function of the school. Okay, the parade includes 4 different students holding various color flags: red, blue, yellow, and white. Mr. B decides the number of students who are holding the flags of each color in a parade and the order of the students in the parade as well. Okay, the students in the parade always march one behind the other. Fine. Uh, for any pair of the students marching immediately next to each other in a parade, the exact distance that should be maintained between the students depends on the colors of the flag held by the students and the relative order. Fine. Now, further, given the composition of students in a parade, Mr. Bruce always decides the order of the students in the parade so as to ensure that the distance between all the pairs of adjacent students in the parade were minimized. Okay. So if the distance between all the pairs of adjacent students in the parade were the same for more than one order of the students, he will choose any one order at random. Fine. The following table provides for any pairs of students the distance that needs to be maintained between them. Okay, so front back we are given with these 4 colors, and the distance between them depends on the order of the flags, isn't it? For example, if you have red and red flag followed by red flag, so the distance between these 2 persons should be 20. Now, if you have 2 persons holding red flag and blue flag, and if the person holding red flag is in front of blue flag, that means blue is blue is back of red color, isn't it? Isn't it? So red is 1 minute back. So blue is back side of red color flag. So the distance maintained should be 15. Now, if you have blue followed by red, now red is behind blue, isn't it? So the distance maintained should be 25 inches. Okay. Same for the remaining flags as well. So if you observe, these 4 questions are independent questions because you do not have a definite arrangement of flags corresponding to these 4 colors, because we are not neither given with the number of students in the parade nor any data with respect to the order of the flags or the order of the colors of the flag that these persons hold. So these four questions are independent questions. So this is an open set. But if I have to choose sets from this paper, I will be attempting second, followed by fourth or third, followed by third or fourth. I will be attempting this set last. Okay, because whenever you come across these type of sets, the confidence that you have in solving a question will not be that much, because I will be always there will be a fear of missing at least one or two cases in these type of sets. Okay, and you should be very careful while solving these type of questions. Okay, now, so the first question is considered to be hard because there is a flaw in this question. Otherwise, that's an easy question. Now, second one is the easiest of all. Set theory easy to moderate, puzzles easy, and the fifth puzzle moderate, doable but moderate. So you can attempt two of these three for sure. You should be in a position to attempt two questions out of two sets out of these three. And if you are good at logical reasoning, you can also attempt these three. Isn't it? So the minimum number of questions that a person can attempt should be 10 or at least 8 in this case. So if you have skipped question number 2 just by looking at the graph, please don't repeat these mistakes in GAT. Okay, so just spend some time to understand the question, analyze the question. Then if you feel that that question is difficult, then you can skip. Clear? Now, so using the clues that were mentioned here. Okay, for row 1, there are 4 bags, each represented by a filled circle. I have not included that table here. Okay, so that we'll get some space to practice or to write. So each bag has a certain number of cherries, x minus 3, x plus 4, x and x plus 2. So for example, we know that among the 4 bags in the first row and of the first column, the number of cherries will be 2, 9, 5 and 7. 2, 9, 5 and 7. Now here, this will be in the order x minus 3, x plus 4, x and x plus 2. So here we are given that x is equal to 8. So this will be 5, 12, 8, 10. In column 3, x minus 3 is equal to 7, x is equal to 10. This is 7. So if x is equal to 10, 7, 14, 10, 12. And in the last column, x plus 4 is equal to 12, x is equal to 8. So x minus 3, 5, 12, 8, 10. Clear? Now similarly, you can also fill the values for A, B, C, D in row 2. So 4, 6, 9, then 2, 4, 8, 3, 6, 12, 5, 10, 20. These should be the values of A, B, C, and D respectively. So here, this should be 4, 6, 2. Sorry. For third row, this should be 4, 6, 2, 3, 7, 4, 2, 10, 8, 4, 9, 5. And for fourth row, you can find the values of R. If you can find the value of R, you can find the value of R minus 1, 3R and 3R. So the value of R is equal to 3 here. So this you can find by, if this is R minus 1, the sum of the numbers in all these 4 cells should be equal to sum of the numbers in all these 4 cells, which are in the diagonal direction. Okay, using which you can find the value of R. So if you have these two tables, you can answer any question from this set. Now, what is the ratio of the total number of cherries kept in all the bags of the second row of column 4? Second row of column 4. Okay. So 10, 5 plus 10, 15, 15 plus 20, 35. Each to, so okay, 35. Sorry, my bad. 35 is to the total number of cherries kept in all the bags of the first row of columns 2 and 4. 35 plus 35. So 35 is to 70. So 1 is to 2 should be the answer. Now find the total number of cherries kept in all the bags in fourth row of columns 1, 2, 3, 4. So 5 plus 8, 13, 13 plus 10, 23, 23 plus 18, 41. That should be the answer for this question. Now, what is the total number of slots for which the average number of cherries in its respective bag is an integer? Okay. Now here, average a number of cherries in its respective bags. So here in this row you have 4 bags, 3 bags, 3 bags, and 2 bags. Now, is 23 a multiple of 4? Now, when will we have an integer value for average? When the sum is an multiple of number of observations. 23 is not a multiple of 4. 35 is not a multiple of 4. Neither 43, neither 35. Now 19 is not a multiple of 3. 14 no. 21 yes. 35 no. Now 3, 12 yes. 14 no. 20. Sorry. 20 no. 18 yes. So this no, yes, yes, and yes. So how many? 1, 2, 3, 4, 5, 6. So the answer for this question should be. Now the number of slots for which the total number of cherries in its bag strictly exceeds 22. So we have 1, 2, 3, 4, 5. That's it. 5. That should be the answers for this question. Okay. So you can solve this question once you put the entire data here in like in these two tables. You can solve this question in less than, let us say, 12 minutes. Okay. So in 12 minutes, you'll be having 12 marks with you. And trust me, most of the students will solve this question. Now coming to the next question or next set. Yeah. So 7 colleagues A, B, C, D, E, F, and G decide to watch a movie on exactly one among Friday, Saturday, and Sunday. So you have 7 people watching a movie in 3 days. So on each day you'll be having at least one person, or more, on some days you'll be having more than one person also watching a movie. And they visited exactly one fast food joint among Domino's, McD, and KFC. Okay. Now at least 2 colleagues and at most 3 colleagues watched a movie on each day. So 2 plus 2 plus 2, 6. So you have total 7. So you have 2 persons watching movie on one day, 2 persons the second, and 3 persons on the third day. And at least 2 and at most 3 colleagues favor each joint. So you have 2 persons or 2 colleagues favoring one joint, 2 colleagues favoring the other, 3 colleagues favoring the third. Now A watched a movie on Friday. Okay. So A did not watch movie on either Saturday or Sunday, and he is not a Domino's fan. Fine. Now 3 colleagues watched the movie on Sunday. So you have 3 colleagues watching movie on Sunday. So 2 on Friday and 2 on Saturday. And none of those who watched a movie on Friday visited McDonald's. Okay. So A did not visit McD. So A visited KFC. Fine. Now F and G like McD. So F likes McD, G likes McD. And I can also say that both F and G did not watch a movie on a Friday, because those who watched a movie on Friday did not visit McDonald's, isn't it? So F did not watch a movie on Friday and G did not watch a movie on Friday. Now B and F watched movie on the same day. So you have B and F watching movie on same day. Now B does not like KFC, but D and G like the same joint. Now you have D and G liking the same joint. Okay. Now B and E favor different joints and they watched movie on different days. So there is nothing common between B and E. Now no two colleagues who watched the movie on the same day visited same fast food joints. Now you have F and G visiting McD. So I can say that F and G visited or watched movie on two different days. Okay, and you have D and E liking the same joint. So D and E, they have watched movie on two different days. Clear? Now D and E like same joint, and that cannot be MACD. Because if you have D and D both liking MACD, then it would be there would be four persons favoring MACD, but which contradicts the question. Okay, so this is the information that was given to us. Clear? Now, so B and F visited, sorry, B and F watched movie on same day. Now, if you have F not watching a movie on Friday, B cannot watch movie on Friday. So B either watched movie on either Saturday or Sunday. Now, if F went to McDonald's or if F is favoring McD, you cannot have B favoring McD since they have watched a movie on same day. So it's Domino's. Clear? Now, if B and E favor different joints. Now, if you have B favoring Domino's, you cannot have E favoring Domino's. So he cannot. He is not favoring Domino's, so he is favoring KFC. Okay. So if E is favoring KFC, you cannot have E watching movie on Friday because A is already favoring KFC, and we are also given that no two colleagues who watched a movie on the same day visited the same fast food joint. Now it is also given that E and D they favor, they like same joint. So you have D favoring KFC. Perfect. Now we already have three people favoring KFC. So no other person is favoring KFC. Now if D is favoring KFC, I can say that D did not watch movie on a Friday. So C along with A watched a movie on Friday. So this is what I can info from the given data. So you have three people favoring KFC. Now we already have two people favoring MACD. So C is not favoring MACD. C is favoring Domino's. So we have filled the left side of the table. Now we have to fill the right hand side of the table. Now we need to find the three persons who watched movie on Sunday. So we are left with B, F, D, E, G. Now one case is when both B and F watching a movie on Sunday, or D, E, G watching movie on Sunday. If B and F have watched movie on Saturday, then you should have D, E, G watching movie on Sunday. Now, can we have a D and E watching a movie together? No, because they like same joint. So this is not possible. So now I can say that B and F have watched movie on Sunday for sure. Sunday. Now, who can be the third person along with B and F? Now, B and E, they cannot watch movie on same day. Okay. So E have watched movie on Saturday. Then you also have F and G liking same joint. So you cannot have G watching this movie on the same day as F. Done. So on Sunday, B, D, and F watched movie together. And this completes the set. Clear? Now, moving to the previous question. Question from Venn diagrams. So a partner-based consulting firm was celebrating the success, so they organized a party for employees. In the party, total three types of cold drinks were served, namely Nimca. Okay. This is Sprite, and this is Mountain Dew. Now a total of 400 members were present. Fine. So out of which 22 members did not drink any of the three types of cold drink. So you have only 78% of 400 members having a drink. So 78% of 400, which is equal to 312. So total of 312 members had a drink. And further, it is known that a total of 600 bottles were sold in the party. So if you have 312 members drinking, how can we have 600 bottles being served in the party? The logic is simple. So some of them have had one drink each. So some of them two drinks, and some of them all the three drinks. Clear? And the additional information is given below. So the number of employees who drank both Nimca and Sprite was 5 more than the number of employees who drank both Sprite and Mountain Dew. Now, after reading these 5 statements, I will be starting this set with statement number 5, because we have a definite value here. The number of employees who drank all the three types of cold drink was 80. So the number of employees who drank both Nimca and Sprite was 5 more than the number of employees who drank both Sprite and Mountain Dew. So if this is X, this will be X plus 5. Done. Now the sum of the number of employees who drank Nimca and Sprite. Nimca and Sprite only. Okay. So X plus 5. And who drank Nimca and Mountain Dew only. So if I consider this as Y plus Y is equal to the number of employees who drank all the three types of cold drinks, which is equal to 80, or Y is equal to 75 minus X. So this value is 75 minus X. Done. We are done with this. Now the ratio of total number of bottles of Mountain Dew to the total number of bottles of Sprite served was 37:43. Okay. Which is equal to total number of bottles of Mountain Dew by Sprite. And the cold drinks were served in the bottles only, and no employee drank more than one bottle of same type of cold drink. Fine. Okay. So let me consider N as the number of persons who drank only Nimca. Okay. D only the Sprite, and M only Mountain Dew. Now the total number of persons will be equal to N plus D plus M plus, you have X plus 5 persons drinking only Nimca and Sprite, plus X persons only Sprite and Mountain Dew, plus 75 minus X persons drinking Nimca and Mountain Dew, plus 80, which is equal to total number of persons who had at least one drink, which is equal to 312. Now this is one equation. Now coming to the number of drinks. So these N persons, N, D, and M, each of them had one drink. So the total number of drinks consumed by them would be 7 plus D plus M, plus how many persons drank exactly two drinks? X plus 5 plus X plus 75 minus X, which is equal to X plus 80. So X plus 80 persons had two drinks, plus 80 had all the three. So this is equal to 600. Now if you subtract equation 1 from equation 2, you will have the value of X. Okay. So the value of x would be 48. Now once we have the value of x, we can substitute in all these three places. So this would be 48, this would be 53, and this would be 27. Now we have to find the values of m, n, and d to answer this question. So for that, we are given that the total number of persons drinking Mountain Dew to total number of persons drinking Sprite is given to be 37 is to 43. So drinking Mountain Dew, m plus 27 plus 80 plus 48 by d plus 53 plus 80 plus 27 is equal to 37 by 43. Okay, and once we have the value of x, this the sum of all these numbers should be equal to 302. So we have n plus d plus m plus 53 plus 27 plus 48 plus 80 should be equal to 312, and we'll be having one more equation in terms of n, d, and m, which will be n plus d plus m is equal to 104. Clear? So m plus 155 by d plus 181 should be equal to 37 by 43. Now I can say that m plus 155 should be a multiple of 37, should be in the form 37k, and d plus 181 should be equal to 43k. Now here we cannot find the definite values of m and d. Yes, but we can find the definite value of k, isn't it? Because we will be having the upper limit of both m and d. M and d both cannot be greater than 104, isn't it? And the value of k should be greater than 4. What is 37 into 5? It should be greater than 4 for sure. Clear? So let me take the value of k as 5. So if I consider k as 5, 37 into 5, 165. Sorry. 37 into 5, 35, 185. 185 is equal to m plus 155. This implies m is equal to 30. Okay, so 43 into 5, 15, 1, 215. 215 is equal to d plus 181, which implies d is equal to 34. Now this is when k is equal to 5. So k should be greater than or equal to 5. Why? 37k should be greater than 155 for sure. You cannot have 37 into some number less than 155, because 37k is equal to m plus 155 and m is an integer. Okay, so I can say that k will be definitely greater than 5. So if m is equal to 30 and d is equal to 34, what will be the value of n? N will be 40. Okay, now if I assume k to be 6, now m plus 155 is equal to 37 into 6, 222. 222 minus 155, which is equal to 57. So M is equal to 57. Fine. Now D plus 181 is equal to 43 into 6. 43 into 6. 18, 1, 258. Now 258 minus 181. This implies D is equal to 77. Okay. Now M is equal to 57. D is equal to 77. What will be the value of N? 104 minus 57 minus 77. Now can we have the value of N in negative? No. Because N is number of persons drinking only in income. So that cannot be negative, isn't it? Okay, so this case is not possible, or the value of K cannot be greater than or equal to 6. So the only value of K that satisfies this set is when K is equal to 5. So when K is equal to 5, the value of M is 30, D will be 34, and N will be 40. Now we have a definite values for all these regions, or all the variables that we have considered. So this completes the set. So I consider these three questions to be doable questions. Now coming to the first question. Now if I eliminate this statement, if it is given that the total number of cars in the museum was 80, okay, no car was sold or added to the collection during the period from 2016 to 2019. Okay, if the number of vintage cars in the museum which have become older than 80 years between 2016 and 2019 is represented by X, the least possible value of X. Now here I can say for sure that a minimum of 12 numbers cross the age of 80 years. Okay, so here it is 2, here it is 7, right? So 12 of convertible, 2 of hatchback, and 7 of coupe have crossed the age of 80 years. So minimum of 21. And if you are asked to find the maximum, you cannot determine that. Okay, because you can also have these 24 cars being crossing 80 years old in the year 2009, and you can have 12 cars whose age is, let us say, 64 years in the year 2016, and which were added to the vintage cars in the year 2017 or 2008. Anything is possible, but I can say that a minimum of 21 cars have crossed 80 years age in the year 2019 first. Okay. So you can answer this question only if you neglect this statement. Okay. Now if the of all the cars which get 62 years old are given a tag of L1 vintage cars, and all L1 vintage cars on getting 65 years old become vintage cars, then the number of L1 vintage cars in the museum in 2016 was the highest of which type. Okay, so cannot be determined because we are not given with the data, isn't it? Such that these cars are of level 1, because n number of cars, any number of cars can be of the age 62 years old, isn't it? So the answer for this question should be cannot be determined. Now in this question, so into if the number of vintage cars in the year 77 to 80 years old group in museum 2016 was the lowest possible, then which of the following statements is definitely true, given that the museum had no vintage cars which were more than 80 years old in 2016. If the number of vintage cars in the 77 to 80 years old range, okay, was the lowest possible, Then which of the following statements is definitely true given that the museum had no vintage cars which were which were more than 80 years old in 2016? Okay. In 2019, the average age of vintage cars over the age of 80 years was the highest for convertible type. So we cannot comment on that. Can be, or it can be highest for hatchback as well as coupe, isn't it? For example, out of these 24 cars, 12 cars have crossed the age of 80 years by 2019, isn't it? So all the cars can be of 77 years old, or they can be 78 years old, 79 years old, which will be crossed 80-year-old mark either in the year 2017 or 2018 or 2019. Okay, so without the distribution we cannot answer, or we cannot say for sure that the average age of vintage cars over the age of 80 years was the highest for convertible type. For example, if I consider hatchback, what if the age of both the cars in the year 2016 was 80 years? So in the 2017, they were decategorized from vintage cars. Then the average would be 79 years. Now, if these 12 cars are of 77 years old, then the average would be highest for hatchback, not convertible. Okay, so this cannot be inferred for sure. Now in 2019, the average age of vintage cars of the coupe type was more than 80 years old. So we cannot also comment on that. So you have 7 cars being discategorized as vintage cars by the year 2019. What if the cars were around 79 years old as on 2016? In that case, this statement is true. Now, what if the age of these cars was 77 years old in the year 2016? So they will be exactly 80 years old by the year 2019. Okay, so you cannot say that. Now in 2019, the number of vintage cars over the age of 80 years in the museum was more than 10. Perfect. This is the right answer, which we have solved for question 1. Only if I neglect this statement, it is given that the total number of cars in the museum was 80. So C should be the answer for this question. Now, if the number of vintage cars which were older than 80 years between 2016 and 2019 of coupe type was more than that of any other type, what was the highest possible number of vintage cars which crossed the age of 65 years between 2016 and 2019 in the convertible type? So the number of vintage cars which were older than 80 years between 2016 and 2019 of the coupe car was more than that of any other type. So the maximum value of this could be 16. So these 16 cars were more than 80 years old in the year 2019. Now, how do we have 9 cars here? So there will be some cars whose age is, for example, let's consider 64 years in the year 2016. So they will be categorized under vintage cars. Okay. So if I assume that these 16 were more than 80 years old by 2019, so this can be the maximum possible value, and it is given that this number is the maximum for coupe type. So for convertible or hatchback or sedan or minivan, so the number should be definitely less than 16. Okay, then what was the highest possible number of vintage cars which crossed the age of 65 years between 2016 and 2019 of convertible type? Okay, so from these 24, let me assume there were 15 cars which have become more than 80 years old in the year 2019. Okay, but by the end of year 2019, the total number of vintage cars were 12. So how do you have 12 here? So after these 15 exiting this category, 3 cars have entered this category from this 24. Okay, so the highest possible number of vintage cars which cross the age of 65 years of convertible type will be 3. Okay, so you can solve all these questions once you neglect or once you do not consider this statement. And coming to the last set of this paper. Okay, so these are independent questions. All you need to do is you need to identify the cases which leads to the minimum distance between all the pairs of adjacent students in the parade. For example, for 21st, if Mr. B wants to start a parade comprising 2 students with red flag and 2 students with blue flag, so you will be having 2 students holding red flags and 2 students holding blue flags. So what can be the arrangement be? RR, BB, or BB, RR, then RB, 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 BR, then you'll be having BR, 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 RB. Now, did we miss any other arrangement? Total arrangements will be 4 factorial by 2 factorial into 2 factorial, which is 24 by 4, which is equal to 6. Okay, so we have considered all the 6 possible arrangements. Now, if the students are in this order, red and red, so you'll be having 20 plus the distance between them. Now, red and black, so red and blue, 15 plus blue and blue, 10. So this is nothing but 45. So the distance between the students, or the total distance between the first student and the last students in that parade is 45 inches. Now, if I consider this arrangement, blue and blue, 10 plus blue in front of red, blue in front of red, 25 plus red and red, 20, which is 55. So this can be eliminated. Now red, blue, red, blue. So you can also find the distance between the first student and the last student. You need to find the total distance between them. And we are given that Mr. Bruce always decides the order of the students in the parade so as to ensure that the distance between all the pairs of adjacent students in the parade was minimized. That the distances between all the pairs of adjacent students. So you need to have a minimum distance between the first student and last student. Okay, so you need to consider the cases for all these questions. So if you miss any of the following cases, and if that case being critical, then you will be losing marks. So in these type of questions, the confidence with which you mark answers might not be that great. Okay, so always keep these type of questions to the last, so that if you have around any odd time left, for example, let us say 5 minutes or 4 minutes at the end of the session, you can attempt these type of sessions, these type of sets. Okay, so overall, this is an easy paper. So 10 questions can be attempted. So if you find second question easy, so if you have skipped that question, then you should be in a position to solve a question set number 3 and set number 4. Okay, so 10 questions can fetch you 95 plus percentile in this paper for sure. And to cross sectional cutoff, then 4 plus 3, 7 questions might fetch you more than 85%. Clear? So thank you guys. And all the best for your next mock. So please kindly analyze the mistakes that you have made in this paper and make sure that you're not repeating the same mistake in the next.